So today, we'll start chapter 1. So in this chapter, we have like a lot of points we need to cover. So basically, we have these 7 points. So the first point and second point, this is what we need to cover today. So basically, we need to like give you a quick revision on the dimensions and units. This is something you had studied in mass and energy balance or engineering calculations. So in engineering calculations course, you should have this part. So this is just a quick revision to this part. And then we will go over the importance and talk about your role as engineers in any field related to energy, what are the importance in energy, how energy related to thermodynamics. So these main things that we need to cover. So this is just a quick overview, and starting from next lectures, we will start to talk about the history, thermodynamics, what is meant by thermodynamics, and continue the chapter we have. Okay. So the important thing that we have from this chapter that you know what is meant by chemical process, what is meant by system, what are the types of system, the concepts of equilibrium, forms of energy. So all of these things that we will cover as we are proceeding with the content we have. So let's start with the revision, the dimensions and units we have. So basically you have studied before that if you have any physical quantity, so this physical quantity is characterized by a dimension. And this dimension, you are describing it with numerical value and with units. So this is why units is very important. When I ask you to calculate anything, it's not enough just to tell me, okay, so the distance is 6 or the mass is 10, for example. So you should tell, okay, it's 6 what? What is the units of this one? Is it 6 feet, 6 kilometers, 6 miles? So this unit is very important. Okay, so make sure that in your exam, in any course, when you put a number, just make sure that what is the units of this number. Okay, so for example, when I tell you if I have the distance between here in Rolla and St. Louis is 106 miles. So basically, miles, this is the unit we have. So this is something you should put. You cannot ignore it. 106, this is the numerical value of your quantity. Okay, so this is the unit, this is the numerical value. And the distance, this is our dimension that we are measuring. And distance, this is the dimension of length. So basically, when I tell you the distance is 106 miles, so I'm telling you the length that we have between 2 points, 2 cities, to whatever we have, is 100.6. This is the numerical value. And the units of this number is miles. So let's say, for example, I give you this example. We have density of water is 1,000 kilogram per meter cube. Okay. So basically, kilogram per meter cube, this will be the unit we have. Okay. And 1,000, this will be the numerical value. And what is the dimension of density? No, density is not the dimension. So the density, this is the quantity we are measuring. This is the measurable quantity. But density is in kilogram per meter cube. Kilogram representing what? Mass, time, length, mass. Meter cube, this is volume or length cube. So we have the dimension of density, it's mass by length cube. So this is the density. Okay. So make sure that any measurable quantity, it has dimension, it has numerical value, it has units. You should consider all of these things. So basically, there are several tries in order to unify the systems of units we have. There are several systems that you are using to express the quantities we are using to express the units. But the most common two systems are the metric system, international system, SI system. This is what most of the students be familiar with or feel comfortable to using in examples. And then we have the English or the American system. The main differences between these two systems are what are the units we are using to express the main dimensions or the fundamental dimension we have. So let's say length, for example, this is one of the fundamental dimensions. So if you express length as meter, then now you are using the SI system. If you express length in feet, so this is the American system. We have mass. You can express mass in kilogram. You can express mass in pound mass. So this is the systems we have. Time, second in both of them. Temperature, it can be Kelvin or it can be Fahrenheit. So this is the difference of these two systems. what is the units that we are using to express your measurable quantity or your dimension that you are measuring. Also, it's important when you solve any example, you should have consistency in the units or consistency of the system you are using. So all the numbers of your problem should be in the SI system, for example. All the number should be in the American system. You cannot solve any problem that you have combination of these two systems together. So from the beginning, when you read any example, just look for the given information you have. Do you have consistency of the system of the units in the given information? Or you should make like a conversion of these things. You should convert one to another and so on. Okay, so always keep this in mind. And again, this table, we have some basic dimension in the SI system. Most of the problems we will have in this course, it will be in the SI system. Okay, so, and also the conversion of units, you will not like, you may have in assignments, for example, because assignments you have a lot of time that you can make the conversion, but in exams we have everything in the assignment. So there's no need to worry about this conversion of units during the exams, but you may face this in the assignments. So this is very important to practice this one. And here, conversion of unit, this is something that seems very basic. It's very easy, by the way, but any mistake in this one, it can like lead to disaster. So I remember that this was like 20, 25 years ago. There was a rocket that sent by NASA to, it was supposed to send by NASA to the space. Then it failed. All the crew passed away because of this explosion they had. And when they figured out the mistakes, the only mistake they have, that the engineer who's working on this project, he, by mistake, failed to convert inch to feet. So this is very like basic like error that or mistake that he did, but it cost millions. We have almost 7 people passed away because of this mistake. So again, this is very simple. It's very easy, but any mistake in this one that you even can see in the number. Someone, even myself, when I have like previous exams, students can say we have like a factory, for example. But because he did a mistake in the conversion, he can say, okay, so the distance or the length of the pipe we have in this factory, it should be like 10 miles. Which doesn't make sense. You can't have a pipe inside the factory with this length. So just if you notice any like numbers that doesn't make sense or not logic to you, then one of the things that you should like consider, do you like have consistency of the units? Did you miss any conversion of the units? Because if this simple mistake can lead to like nonsense numbers. Clear? Okay. So this is table just to give you like a quick overview of the basic dimensions we are using in the SI system. Okay, let's take a quick example just to remind you how we can make this conversion of units. So let's say we have 23 pound mass feet per minute square. And we need to convert this one in kilogram centimeter per second square. Okay, so how we can do this conversion? So basically what we are doing is the following. So this is our problem we have. This is the number that we need to convert. This is the original units that we need to convert. So the key here is to know, so what unit is equivalent to the other. So originally what I have and the new what I have. So here I have minute. So I need to convert this minute into second. I have feet. So I need to convert this feet, this length to centimeter. I have pound mass. I need to convert it to kilogram. So the first one, you should know what is equivalence of the units we have. So pound mass equivalent to kilogram. So okay, I need to convert pound mass to kilogram. Okay, feet to centimeter, minute to second. This is the first step you have. Sometimes I see students that you're looking for like converting pound mass to kilogram for pound mass to centimeter. This is not the same. Pound mass kilogram, this is mass. Feet, centimeter, this is length. So you should know the dimension, or what dimension this unit is representing. Then we have like tables for this conversion. If you look in these tables, I will upload these tables in Canvas, just 2 pages to be simple. So when you see it, so now you need to know what is the relationship between, or the conversion factor between pound mass and kilogram. So in this table, you see that 1 pound mass is equivalent to 0.45 kilogram. What is the equivalence or relationship between feet and centimeter? So 3.28 feet equivalent to 100 centimeter. And for sure, 1 minute is equivalent to 60 seconds. So what we have here, so we should make like something like this line and start to put your like the given in the example. So here we have 23 pound mass feet per minute square. So this is what I need to convert. So start by converting every dimension. So how we can do this? So now let's start with pound mass. I know that 1 pound mass equals 0.4536 kilogram. So what you should do? Here we have pound mass and the upper side. So you should take this conversion as is and put it here. So here we have 1 pound mass. And equivalent to 0.4536 kilogram. This is the first dimension. Then go to the second one. So what is the second one? Let's consider feet. 3.28 feet equal to 100 centimeter. So when you put 3.28 feet, is it in the up or down? Down, because originally feet in the upper side. Okay, so we have here 3.281 feet. This is equivalent to 100 centimeter. Then the last one, minute to second. Here I have minute originally down. Okay, so I put here 1 minute. And here I have 60 seconds. But here I don't have minutes. I have minute square. So you should square everything in this last conversion. So this one will be 1 square, minute square, 60 square, second square. Only the last one. If it's cube, so everything will be cube. So far is good? Questions? Questions? Clear? Clear or no? Yes, clear? Is it clear? Just making sure that you're following. Okay. So now what I have, how I make sure that the number that I will calculate at the ends will have the required units. So basically, see any unit in the upper side and any unit in the downside, any unit is repeated, so cancel each other. So here I have pound mass, and here I have pound mass. So these are cancelled. Here I have feet, and here I have feet. So these are cancelled. Here I have minute squared, and here I have minute squared. So what is remaining? Kilogram, centimeter per second square, which is required here. So only the units the new units that are required, only this is what is remaining in the problem we have. So now, after doing this, so the new number will be multiply all the numbers in the upper side together. So we have 23 times 0.4536 times 100 times 1 square divided by 1, 3.281 times 60 square. And what will be the number? Did you calculate it? 0.088, okay, kilogram, centimeter per second square. And this is what is required. So basically, 23 pound mass feet per minute square. This is exactly equivalent to 0.088 kilogram centimeter per second square. I can hear. Not make like questions? Is it clear? Any questions? Okay. So this is how we convert units. So this is basically when I tell you like 1 meter contains like 100 centimeters, for example. So this is exactly the same. So this is how we make conversion of units. Okay. Any questions? Cool. So the other thing that also we need to remind you of, which is called dimensional homogeneity. So dimensional homogeneity, this one tells you if you have an equation, so this equation should be dimensionally homogeneous. And what this means any additive term in the equation, in any side of the equation, should have the same dimension. Okay, let me give you an example for this. If I give you this equation, U equal U dot plus GT, for example, and I tell you U, this is velocity. So the units of U is meter per second. So now the left side of the equation is meter per second. So dimensional homogeneity means that, so the right side of the equation must be meter per second. Each term or each additive term of the right side should have the same dimension and the same unit. So U dot should be meter per second. GT together should be meter per second. G is gravity, it's meter per second square. T is time, is second. So meter per second square times time together is meter per second. So this is what is called dimensional homogeneity. Each term or each additive term in any side of the equation should have the same dimension, should have the same unit. If any equation doesn't fulfill this condition, so this equation mathematically is wrong. Okay? So now it's very important to know that the conversion of units, systems of units, and the dimensional homogeneity, these are the mathematical or basic of mathematics that you need to solve any problem. Clear? Any questions? Okay. Let's take also this quick example. So example tell you we have an equation D, which is feet. So D is length. Feet is a unit of length dimension. Equal 3t, t is time in second, plus 4. So here I ask you, if this equation is valid, this equation is homogeneous, what will be the dimension? What will be the units of numbers 3 and 4? Okay, so how we do it? So this is the equation we have. I have D equal 3t plus 4. So this D is in feet. So this is the unit we have. And this feet, this unit, representing or express a dimension which is length. So each term of the equation should have or represent length in feet. So now let's consider the easiest one first. So I have this number, number 4. So what will be the dimension of this number? Length. And what will be the unit of this number? Feet. Clear? Okay. Now let's take this number here, number 3. Here we have this t, this is time in seconds. 3t together should be length in feet. So what will be the dimension that number 3 is representing? Is it length? Only length? So what it will be? L over. Yes. So this will be length over time. That will be feet per second. So feet per second times second, second will be cancelled, and the remaining will be feet. So this is an example of the dimensional homogeneity. Clear? Any questions? Any questions? Good. Any questions? Okay. So this is the first part that we need to cover. Just a quick revision of the system of units, conversion of units, and dimensional homogeneity. Any doubts? Anything not clear? Should we repeat? So now let's start with like a quick overview of the thermodynamics, but this will be a general overview. We will not start talking about the thermodynamics, history of thermodynamics until next lecture. But in order to understand thermodynamics, then we need to know that thermodynamics is something related to energy. And energy is everywhere. Everything you see in your daily life, this is an example of energy. Okay. We are using energy every day. The phones that we are using, the devices that we have right now. So even our bodies, this is an example of energy users. Okay. So energy is here in every place at any time. Okay. And thermodynamics is like the science that we are using to understand energy and study energy. So again, energy, you can find it in industry. You can find energy in transportation. You can find it in utility, electricity we have, even the water systems that we have. So all of this relies on energy. Governmental sectors, residential, even public. So everything we have in life, it uses energy. Okay. Okay. And its uses start from even our bodies. So our bodies is an example of the energy users. In the refrigerators we have, the engines we have in our cars, even power plants, large power plants we have. It expands from very small, tiny things to very large things we have in your life. Okay. So energy, again, it's not something very new, but we are using energy from like thousands of years in different forms. But the current form we have now in energy, it started with the Industrial Revolution in 1760. So in this one, when we have like steam engines start to appear using coal in order to produce energy. Now coal is somehow produced by natural gas, by air, but still exists. But by this time in England, so we have in 1760, we have like how we can use coal in order to produce energy. We have steam engines. So starting from this time, so all the industrial revolution start to appear. Okay, so it's something like not new we have. And again, the main source of energy we have nowadays is mainly the fuels. And we have three categories of fuels. We can use, or we can have fuel as solid, we can have it as liquid, we can have it as gas, and with many types of them. So for solid, for example, we have coal, we have charcoal, we have wood, we have all of these examples. As liquids, we have the crude oil. This is the primary one. But still we have gasoline, we have kerosene, we have other types that we can obtain from this one. Gas, mainly we have natural gas. Natural gas, which is the methane, CH4. But again, we still have a lot of other like types we are using. So all of these categories of fuel can be found in any form we have. In order to talk about energy, there's something called 3 E's. So 3 words start with the letter E, and these 3 words are attached, connected together. They are affecting each other. So the first one is energy. But you cannot understand energy, or you cannot study energy without considering the environment and also the economics. So these are the 3 E's we have. So again, these are very connected together. They are affecting each other. So basically, for example, here we are using energy. So energy start to be used. It makes our life easy. We have a lot of like economic growth, a lot of things happen, but at the same time, we are using the natural resources we have. So we have stress on using the natural resources we have. Now we are hearing that within the 40, 50 years from now, we may have depletion of the fossil fuel or the oil, whatever we have. So we need to have new sources that we have. One more thing that also you can see that the inflation of the prices. If just one day you wake up and we have like a difference in the oil price, then the whole world will change. The whole prices will change. I think you can observe this during the COVID, for example. During the COVID, all the prices increased in the whole world. Not single world didn't suffer from this inflation we have for the past 5 years. Also, we have a lot of environmental concerns. So now I think you hear about the global warming, the temperature increase. Did you just in case you didn't hear the news, last year, 2024, so the average temperature on the Earth was the highest one since 1850. So for the past like 200 years, last year we have the highest temperature on this planet. And this because of what? This because of the climate change. This because of the greenhouse gases. And all of these gases is something that comes from the industry. Because of our using of energy. We need more energy in our life. So we have more industry. We have more waste is being released to the atmosphere. And this is called all of these problems. Okay. So this means, yes, we have energy in everywhere. Using energy is very important for our civilization, but there are some drawbacks for using energy. As we can see here in this table, we have just the pros and cons of this one. So we have technological advancement. We have economic growth because of energy users. We have like improved our standards of life. We have communication, better communication. We have now phones. We have like everything. We can communicate with anyone in the world very easily now. We have agricultural productivity, more food in the whole world right now. But at the same time, we We have degradation happening to the environment. We have more pollution. We have depletion in the resources we have. Social inequality, conflicts like inflation, and also we have a lot of health issues because of the all the pollution caused by energy. So this is why here becomes your role as an engineer. So your role as an engineer is to maximize the benefits of using energy and try as much as you can to minimize any drawbacks or any cons of using it. So you as an engineer, you try to develop energy conversion systems. And almost we are now, the whole world is focusing on the renewable energy sources. Now we need more energy from solar, more energy from wind, even nuclear, it's still renewable, it's clean. Okay, so we need to focus on these things more than the fossil fuel. So we need to have a plan for the upcoming 30, 40 years from now. And at the same time, even if we have existing energy systems right now, but we need to design more efficient system. Especially we need to focus on this word, sustainability. So we need to have more sustainable systems. Did anyone hear about this sustainability? Anyone hear this word? What does it mean? Exactly. So this is the most common definition of sustainability. We have some resources. We need to use it efficiently with minimum waste of it, with minimum pollution caused by using it. But at the same time, we need to keep these resources to next generations. So sustainability basically means you need to have better resources use. We need to have better cost effectiveness. We need to minimize the cost. We need to have better environment, better energy security. Okay. And we need to have better design analysis, better efficiency. So these are the whole sectors that sustainability is focusing on right now. And here we have thermodynamics appear. So now we talk about energy, we talk about environment, we talk about sustainability. So the thing that intersect with all of these sectors, this is our thermodynamics. So thermodynamics is the science of energy. But by studying thermodynamics, then you can design new systems, or even you can develop the existing system. And if you can do it in a sustainable way, so this means less cost, this means better environment. Is it clear? So this is why thermodynamics, this is an important course. Again, it's almost, I think, 3 or 4 disciplines in engineering, they study thermodynamics. So it's there, I think. And for sure, we have chemical, environmental studying it, but I know that mechanical engineers also studying it. Sometimes civil engineers, they need to study thermodynamics at the end. So it's there. So thermodynamics is very important. It combine a lot of concepts together, and it's very important in the life matters right now. Any questions? Clear? Okay. Last thing that I want to mention with you is because of this concern of sustainability. By the way, the term sustainability appears only 50 years ago. Before that, there is no even word called sustainability. No one was focusing about the pollution that caused of these industries. But 50 years ago, that we start to figure out the amount of significant pollution released, then the whole world, not like a certain country, but in Europe, here in the States, even in Africa and Asia, they start to focusing on this concept sustainability, increase using it. So we'll find only this term is still a brand new term. But we have the United Nations, recently they defined some sectors that if you want to think about the sustainability, so we need to think of these 17 sectors. Okay. So if we just want to read them together, so the first one, the first criteria, the first sustainable development goals is to ensure that there is no poverty in the world. The second one is zero hunger. Then we have good health and well-being. So you know that even in the States, there is a statistics last year, more than 100 million people, they suffered from water problems. Just they get diseases from the quality of the water they are drinking. And this is a huge number here. This is almost 1/3 of the population in the States. Okay. Now, if we go to certain countries in Africa, for example, then this number would be get more and more. Okay. The quality of the education, this is one thing of the sustainable development goals are looking for. This is why you can see a lot of scholarships from governments, even from private sectors, for different people that they ensure that people have a chance for good education. Gender equality, I think it's there. clean water and sanitation. This is an example of what we are saying right now. Here, the one that's focus on clean energy. We need clean energy sources. We need to reduce our reliance on the fossil fuels that cause a lot of problems. We need to keep them as we still are using them for sure, but we need to minimize at least the pollution that is generated from using this. We have the economic growth. It's very important. Also, we need to focus industry, innovation, infrastructure, inequalities. We need to minimize these things. Sustainable cities, sustainable communities. We have responsible consumption and production. Again, we are suffering a significant problem over the resources depletion, so we need to be wise in using these things. Climate action, the increase in the temperature in the world. There's a whole, there is a conference, it's COP conference, like climate change conference. Every year in different country, people sit, scientists there, even people from the government, and they start to think, what can we do in order to avoid this rise in temperature? Because a lot of countries will be negatively affected by this one if this continue to increase. So it's not like a simple thing we are considering, but on the long run, this can be a disaster to the world. Okay. Water, live polluter. A lot of pollution is caused in the oceans. Even so far, we can say this is also an statistics for 2023. Like 80% of the waste streams, liquid waste that is released from industry, they release it to the oceans without treatment. And this is a huge number, 80%. Even you hear now about the plastics, not like throw plastics in the oceans and these things to, this is very harmful to the fish. So all of these things now are very important. Okay. We have life on land. We want to make it like green as possible. Then we have peace, justice, and institutions, and we have partnership for these goals. So again, these are 17 sustainable development goals. Sustainability, this is something now related to thermodynamics. So now when you are studying thermodynamics, yes, this is a core course we have in engineering, but now this course have a lot of applications for the future. Okay. Is it clear? Any questions? Sure. That's it today. We'll not continue. Next lecture, we will start talking about the history of thermodynamics. Think now the first quiz is announced on Canvas. If you check Canvas, you should have access to the first quiz. So this quiz due is before the start of next lecture. So make sure that you solve it by this time.